pretty sure I could probably do it blindfolded at gunpoint if someone demanded it of me. Isotopes are everywhere. Every natural system you can think of probably has some way to use stable isotopes as a tool. There's not only stable isotopes of carbon, hydrogen, nitrogen, oxygen, and sulfur, which make up the backbone of pretty much every organic molecule on our planet, but there's isotopes of other elements like strontium, elements that are in rock, in minerals that you can use in geology, astrobiology, climatology, paleoclimatology. There's really no shortage of applications.
I was able to convince the dean in the College of Arts and Sciences that as part of my appointment, that one of the things that would be good for the entire community would be investment in instrumentation that allows us to measure the isotopic characteristics of things like water, soils, plants, and animal constituents.
One of the ideas that we're looking at is using isotopes to increase the sensory awareness, so to speak, of the Arctic domain, using isotopes to help understand where different storm systems are coming from, the traits of sea ice, the movements of sea ice, and where that open water is headed. Are we getting more precipitation in certain parts of the terrestrial environment? And some of these questions we can begin to answer with isotopes. Essentially, they act as a tracer.
So this is the ENRI Stable Isotope Lab at the University of Alaska Anchorage. And right now, I'm working at one of our water isotope analyzers. We run a lot of water samples. We have a network that analyzes isotopes in rainfall for oxygen and hydrogen isotopes called the U.S. Network of Isotopes and Precipitation. So that's a data set that has about 30,000 data points of individual rain samples that have been collected all over the U.S. In the course of an average year, I probably run between 40 to 50,000 samples for faculty here at UAA and researchers in Alaska and around the Anchorage area.
In marine systems, the isotopic characteristics of the surrounding waters, which vary spatially, are actually imprinted upon the food web. And so if you have fish that are illegally harvested in, let's say, the Arctic basin, you can distinguish those from the same species that might be harvested in an area where commercial fishing is allowed, for instance, the Bering Sea. And so part of our mission was to really begin to identify in very fine detail this variability that occurs throughout this food web, all the way from Kodiak, all the way around into the Beaufort Sea.
Having done this now for about 10 years, I'd say a good rough estimate is somewhere close to about 500,000 samples or so, give or take. I could probably do it blindfolded at gunpoint.